Okay guys, what we're going to be looking at now is the next in our special binomial products, and that is the difference of two squares. That's the name of it. Okay, now we're going to talk about what that name means at the end of the video, because actually I want you to see what happens first. Okay, so we're going to explain why we have that name at the end. All right, so with the difference of two squares, what we're actually looking at is a plus b, a minus b. And you can see that this is still a binomial product. You've got two things multiplied together, okay? What you can also see is that the letters are the same in both, so they both have an A and a B in them, but one is plus and one is minus. So basically the brackets are the same, except that one has a plus in between them, one has a minus in between. Okay, this is something you're going to need to look for in the future. We're going to start by expanding this out to have a look at what we get, and then we're going to talk about the shortcut again, just like we did with perfect squares, and also what it means, why we call it the difference of two squares. Okay, so the first thing we want to do is expand this. So we're going to do good old FOIL again. So F is for firsts, so we get A times A, plus O is for outsides, A times, and be careful here, it's A times negative B, okay, plus I is for insides, so B times A, plus L is for lasts, so B times negative B. Also be careful there. All right, let's simplify all of this. So A times A is A squared. A times negative B is going to be minus AB. B times A, again, remember, we always write them in alphabetical order, so do not write BA. We should be writing plus AB. And then we have on the end B squared, but it's also going to be negative, so minus B squared. Okay, now, as usual, we need to tidy this up. So if you look at these terms in the middle here, these two terms, minus AB plus AB. It's an interesting one because what that actually does is it cancels out. Okay, so we can actually put a nice little cross through them. They're gone. They're both gone. And what we have left is equal to A squared minus B squared. And this is our final answer. Now, this is our shortcut. Okay, so if you have, I actually don't need to scroll up here. If you have A plus B, A minus B, the answer is just the first term squared, okay, because we had A here, it's the first in both of them, so we get the first one squared, minus the second term in both brackets squared, so it's going to be B squared, and that's it. Okay, so you don't have to go expanding it and everything. If you see that the brackets have the same letters, but one's a plus and one's a minus, then you can just do the difference of two squares. Now, that comes back to the original question I mentioned. Why do we call it the difference of two squares? Okay, this doesn't look like there's no square in here at all, so why do we call it the difference of two squares? Well, actually, we name it after the final answer. Okay, if I said to you, I want to know the difference between your age and your little sister's age. Okay, so I wanted to know the difference between your age and your little sister's age. What you would do is you would take your age and you would subtract your little sister's age. Okay, what we have here is one square, so the first square is A squared. Okay, down the bottom here we have square number 1 minus square number 2. Okay, and that's a difference because you're subtracting it. It's a difference of two squares. Okay, so this is why we call it the difference of two squares. Okay, now let's do some examples just to make sure you guys get it. It's pretty easy. All right, so if we have, for example, x plus 3, x minus 3. Okay, so the trick was, if you look up above, we're going to take the first term. So the first term in both is x. So we're going to, I'll just colour it first. We're going to take that and square it. So we're going to get x squared. We put a minus in. Take the second term in both. So we've got 3 and 3. So over here we're going to put 3 and squared. All right, which just becomes x squared minus 9. And we're done. So that saves you a lot of work not having to do all this expansion if you see this pattern, okay? And we really, really want you to do this, okay? This is one of those times when we teach you a trick, and if we teach you a trick, that means it's important, okay? This is going to save you a lot of time in the future. If you sit here expanding everything all the time, you're going to really slow yourself down, okay? So we teach you this so that you use it, okay? So let's do another one. A plus 4, a minus 4 is equal to, okay, so we get first one squared is a squared minus second one squared, so 4 squared. So it just becomes a squared minus 16. Done. Look how nice and quick that was. All right, if we do b plus 7, b minus 7, we get b squared minus 7 squared. So we just get b squared minus 49. Okay, let's try one with something different. So for example, 3c plus 5d, 3c minus 5d. Okay, and that's going to be equal to, and now again, this time you need to make sure you use brackets, 3c squared minus, the next term was 5d, so 5d squared. Okay, and if you don't use brackets, you will forget to square that first term, the first number, the coefficient. Okay, the coefficient is that number in front of your algebra, your unknown, your variable. Okay, you must square the coefficient as well. So 3 squared is 9, so we get 9c minus 5 squared is 25d, and sorry, they should both also be squared. Okay, that's it for difference of two squares. Please learn it, please use it. Okay, we teach you these shortcuts so that it saves you time in the future. Okay.